A few things real quick. Again, we are on Rumble and whatnot. This is being live streamed and recorded, so there will actually be quite a few people watching this over the next several days. I'm quite certain of that. After the speaker, the speaker will be up here and talking. If you have a question, I need to ask you to come up and use the microphone here, and that is so that the people at home can hear what the question is. And so, please speak into the microphone like this. It's not omnidirectional. If you hold it like this, it doesn't work. So hold it like this if you would, okay? Appreciate that. Okay, couple of quick things. America 250, this year, this coming July 4th is the 250th anniversary of the Declaration of Independence, of the birth of our nation. And it's really something to be proud of. And as I say, that none of us would be sitting here today if it wasn't for what happened 250 years ago. And so we need to be celebrating what has happened, and we need to do everything we can to protect what our founders created for us. And so, just be aware of that, and please do that. Now, in that sense, too, Stand Up for Idaho, we're as part of the America 250 Commission, and what we're trying to do is we're actually raffling off this flag, and it's going to help us do these things like this. And so if you're interested in buying a raffle ticket for this thing, it's $20 a piece, and we can get it up there. And if you want 1 or 1,000, we'd be willing to sell them to you. We will draw for the flag to give it away right at around the 4th of July this year. Okay, so it's a good way, we think, to celebrate and commemorate the 250th anniversary. It's a very nice thing. It's wood carved. You won't find another one in the country. We had it specially ordered for us. Another second thing, this last few weeks, you'll be hearing about an Article 5 convention or a convention of states and these type things. There's actually a balanced budget amendment that is called HCR 25 that's actually at the Senate right now. It was approved by the House and it's at the Senate. And what it calls for is a convention of states to try and get a balanced budget amendment. Or, and the thing is with this is if you really study in Article 5 and what it means, it is not a good thing. I firmly believe it is not a good thing. And on that note, actually, next week, we're going to have a lady. Her name's Julianne Young. She's a former representative, and she does a very good job of talking about what an Article 5 convention means, what Article 5 actually says in the Constitution, what it means, and some of the risks. So I encourage you to two things. Call your senator today and tell him to vote no on HCR 25. And the second thing is come and listen to Julianne, because once you do listen to her and she explains it to you, then you'll understand why an Article 5 is not a good thing. And it could actually even destroy our Constitution. It really can. The following week, March 4th, we actually have a very special guest coming. And his name is Nick Edwards. He's the chief investigator for the Idaho Attorney General's office, and he's the former Idaho Internet Crimes Against Children Task Force commander. And he's going to come and talk to us about child exploitation trends impacting Idaho, and even here in eastern Idaho. Okay? So just quickly, over the past several years, Idaho has seen a significant increase in child exploitation arrests. In his presentation, Chief Edwards will break down why those numbers are rising, what trends and investigations are seen on online exploitation, sextortion, and social media facilitated crimes, and how technology is being used by both offenders and law enforcement. Okay? And people that come and watch this, they'll gain insight into why arrests are increasing in Idaho, what's happening, current online threats to targeting children and teens, the role of social media, a lot of type things. He hopes that this be a powerful, data-driven discussion towards awareness prevention and the collective responsibility to protect Idaho's children. He's actually coming all the way from Boise to just do this, and because it's an important thing. And so if you could remember it, Mark your calendars, March 4th. Talk to people. We're actually going to be trying to stick some flyers up around town because this is important. I talked to one guy earlier today, and he says, just the topic is disgusting. But you know what? That goes to show of how important it really is, because things that are happening to our kids. So we need to pay attention to it. And with that, like I say, next week we're going to have Julianne Young come and talk about an Article 5. So a lot of things coming up. Well, tonight we were supposed to have Richard Williams, the Director of Engineering of Aalo Atomics, come and talk to us. But he, like work does, and I understand that, got called away. And so he sends his apologies, but he sent his right-hand man, I guess I'll call him that, Luke Andrew. He's the engineering manager for Aalo Atomics, and he's going to talk to us. I'll actually let Luke tell us a little bit about himself and whatnot and what's going on, and then talk to us about the Aalo Reactor and all this, and we'll open it up to everybody. So let's give Luke a big hand. Thank you,
Luke. All right, thank you for that intro. So my name's Luke Andrew. I grew up in Moreland, Idaho, which is just outside of Blackfoot. And so I'm a local, and I work for Aalo Atomics pretty much since it began. Aalo kind of came out of existence from the Marvel microreactor project. I don't know if you guys have heard about that one from the Idaho National Labs. I was part of the team that got the Marvel microreactor project to the 90% final design with DOE to get it approved for construction. And the technical manager from that project on the INL side, I worked for Walsh Engineering at the time. The technical manager from the INL side decided, I'd like to do more. I'd like to get my handcuffs removed with the bureaucratic and the slow pace. Not to point fingers at the Idaho National Labs, but try to do things a little bit faster than what he was able to do. And so he co-founded Aalo Atomics with a guy named Matt Lozak, and that technical lead was Yasser Arafat. I know that's an interesting name, but that is his name. And so they founded Aalo Atomics. It's not Aalo, but it's Aalo Atomics, and it's Bengali for the light. And we started that in just in the fall of 2023, and we've been going like hellfire and damnation to get this thing rolling ever since. And so what are we trying to do? Aalo is, we're trying to build its first nuclear power plant in Idaho, and it's called Aalo-X. Aalo-X is a nuclear reactor that we're building right now, and it's going to be located just south of the materials and fuels complex, just outside of the Idaho National Labs facility. That reactor is going to, we'll probably get into more details into it, but I'll give you the too long don't read. It's going to be a 30 megawatt thermal reactor with 10 megawatts of electricity generated out of it. That's the goal. We'll see how close we get to that, because we are trying to do it in a very accelerated timeline. I don't know if you've heard of the 4 executive orders in regards to nuclear energy that President Trump put out. Well, those 4 executive orders created within the Department of Energy a reactor pilot program. And a lot of nuclear developers signed up to be a part of this nuclear reactor pilot program. And we were accepted into that as well as I think 10 other companies. And the goal of this reactor pilot program is to go critical by July 4th, 2026 for America's 250th birthday. And so we are, again, going balls to the wall to get that to happen. We've got our facility built. We're fabricating what we're trying to go critical with, and we're getting parts delivered and things. If you have ever driven past the materials and fuels complex, you could probably see our building out there getting constructed right now. The materials and fuels complex is where we're at the site. It used to be called Argonne National Lab West, for some of you more experienced people. So, why does this matter? What are the benefits of us doing this here in Idaho? Well, I have a job. I'm contributing to the economy here. We're bringing contractors into the area, which is going to improve the tax base for the city. It's also going to attract economic development. The more we are trying to work with to get this reactor running, the more technology we can prove out, and the more interest into providing electricity for the high consumers of electricity. We call them, I'm probably going to butcher their names, but the larger consumers this day and age are, if you're not familiar, the AI data centers. Data centers are becoming a huge consumer of electricity, and we are in the talks with these people to ask them, what do you need, and let us figure out a way to provide you what you need. And they consume massive amounts of electricity, and we're trying to provide that electricity so it doesn't affect the other, normal people in the world. And not to get too straight off of the subject, but the reason why data centers are important is because for the country to be competitive against the world, we have to be competitive with our technology, and the data centers do help us with that. Also, just providing reliable electricity. I don't know can you raise your hands if there's an Idaho Falls Power representatives in here, or just workers from there? I was kind of hoping that there would be somebody here for that, but I'll tell you what I recall from the meeting that we had with Bear a year ago. Bear has since left Idaho Falls Power, but he did a presentation in this arena a while ago. And he talked about there was a scare for Idaho Falls Power I don't know if you recall, when there was a freeze in the northwest, and Seattle and that area just froze over, and there was a scare for Idaho Falls to have a rolling blackout. And so that's why Idaho Falls Power kind of started talking to us to look for other options to get power option delivery. So you guys are probably here because you have questions. And so it was suggested that I kind of bring up some of these questions that you may be asking and kind of answer them before we even, get to other nitty-gritty parts and pieces. So you're probably concerned, will this be safe for my family and my community? Everything that we're doing right now is to DOE compliance, and if we get a reactor built for Idaho Falls Power, it's going to be to an NRC license, and those guys are not going to let us build anything that's going to cause any concern or danger to the community. We have lots of red tape, so to speak, that we were trying to avoid, but that red tape is necessary. There's quality assurance that needs to be done, and proof that these things are safe. There won't be accidents that will cause harm to the environment or to the public. And so absolutely everything that we're doing, we're planning on doing things safely. I grew up in Moreland, Idaho. I do not want to damage my home. I don't want to damage the mountains. I'm a mountain man. That's why I still continue to live here. Just kind of a short tidbit. They wanted this company to start in Texas, and I refused. And luckily enough, enough people refused to leave Idaho to start the office here in Idaho Falls. So I do not want to do anything that would damage my home, where my family is, and where I enjoy going out into the wilderness and chasing down animals that are smarter than me. So who will I already answered that. Who will ensure that it's safe, and who will regulate it? So like I said, the reactor that we're building right now is going to be licensed and approved by the Department of Energy through that reactor pilot program. I don't know if you guys know the history. They're way back when we were doing the real Atomic Energy Commission stuff, before they split it into the Department of Energy and the NRC. There's two different reasons why there's licensing structures. The Department of Energy is for research. The NRC is to protect the public. They don't care. The NRC doesn't care how big your reactor is. They don't care, is it profitable? All they care about is it going to hurt somebody in the public? That's all they really care about. And so our job is to make sure that the reactor that we're designing is of value. And so we'll kind of get to that a little bit later, but that's who's going to be regulating it, the Department of Energy. We're doing this with the Department of Energy and with Idaho National Labs and the Nuclear Reactor Innovation Center to make sure that this reactor will benefit the country. Will all those power plants harm the environment? So we are designing our reactors so that it will not affect the environment, because it'll make it much easier to get the license if we have a small impact on the environment. So we are trying to do our cooling system. The biggest one to talk about there is the cooling system. We're not going to be using a water source, a large water source, to continually cool our reactor. We're going to use a closed loop air-cooled condenser system to ensure that we don't affect the environment with the cooling system. There will be some makeup water needed, about 5 gallons per minute per 10 megawatts of electricity, which it's not necessarily a small amount of water, but it's not exactly a large amount of water either. That's about the same as running 12 showers a day, I think is what it is. So we're trying to minimize the usage of resources to make sure that we're not using them inefficiently, I guess is the best way to say it. So how will our power plant affect electricity costs? So we're in the stage where it's called FOAK, first of a kind. So the technology that we're using, it's similar but not the same as other reactors. We're trying to do a sodium-cooled reactor, which was very similar to EBR-2, Experimental Breeder Reactor 2. It was a sodium-cooled reactor out there. That was a fast reactor, which was a breeder. It breeded its own fuel, but we're going to be building a thermal reactor, which just means the neutrons don't go as fast. I'm not a nuclear engineer. I'm a mechanical engineer, but this is what the nuclear guys tell me. So what we're trying to do, it has been done, but it's not been done in the configuration that we're trying to do. So again, we're a first of a kind reactor. So it's going to be a little bit more cost. We've got to build up the delivery of consumables to us. We have to build up the manufacturing capability. We have to build up the sources, the material sources and all that stuff. We have to build up that capability. And I don't know if you guys have ever built a shed or built a house or built a car, but you always screw up the first time. You always have lessons learned. You always got to figure out what you're doing wrong to do it better the next time. And that's what a first of a kind usually is. You got to figure out those mistakes and learn from them and do better jobs the next time. And then once we get to an nth of a kind, we're hoping to be in a very competitive price point for Idaho Falls Power or others. So that is on us to make our reactor as cheaply as possible, but don't expect that with the first of a kind. But that's where we're going off to the higher demand consumers, the people that are okay with spending a little bit more money, but they pay the premium because we're going to provide the dependability. Nuclear power is one of the most dependable power sources in the country. So that's where people are going to want us, because we can provide that dependability. We don't have shutdown times as much as other power sources. And so that's what we're banking on, is to provide that dependability so that they're willing to pay a little bit of premium. And then once we've built a couple, once we get to the nth of a kind, so nth means that basically you've hit the point where prices are flattening out. You can't get it much cheaper than nth of a kind. Once we get to that nth of a kind or before, that's when Idaho Falls Power will probably be reaching out to us, because they've got a little bit more interest in it's a power price that they can afford to make it their customer base an option. Who's going to pay for this? So in the MOU, and I have a copy, I'm sure you can get it from the Idaho Falls Power as well, but in the MOU, the Memorandum of Understanding that we've got with Idaho Falls Power, we're going to basically, once we get to that point where our price point is of benefit to them, that we'll start talking about a power purchase agreement, a PPA. I don't know what that price will be that Idaho Falls Power will then be interested in, but they've talked about buying 7 reactors to build out near the power peaking plant. And once we get that built up there, that's where they currently go to a market to buy power which they don't provide themselves. I think they can, and I'm probably going to butcher this, but I think they can produce about half of the load that they need, and then they have to go to a market and buy it off the market, the remaining amount of power. And so the idea here is that they start going to somebody like us, we are going to own the reactors, and then we just have a power purchase agreement that they have a flat rate that they will buy it from us, and then they will put that into the conglomerate, the fungible power delivery to give their power rates. I don't know, that's a question for Idaho Falls Power, how they're going to do that. Are they going to have a separate rate for the nuclear power? Are they going to have that's something that Idaho Falls Power will have to discuss. But what the MOUs basically states is that we will have a fixed price that we will sell our electricity to them when it happens. So we'll move on. So this is April 2024, very shortly after when we started. And this was how many people we had at the time. About half of us are here in Idaho, and about half of us were in Texas or other remote locations. But in a short amount of time, we've grown to about 140 employees as we've proved out what we are doing. We've had to basically we started about 10 employees, and we're a venture capital funded company. So what that means is we basically have to prove, or basically talk to people and say, hey, give us money. We're a good investment. We're going to make you money based off of us being a good investment. And so we made it through the seed round, and we've made it through Series A. We've made it through Series B. And this is about Series B getting to about 140 employees. And we're working on getting to our next series of funding to basically pay for Aalo-X and also pay for our factory. I don't know if we'll talk about it here shortly, but basically we are trying to be I can't think of the word, but we're making everything ourselves. We don't want to be self-sufficient. That's a good way to put it. We're trying to make it so that we don't have to really wait on anybody else. We don't have to be beholden to our vendors. We're trying to figure out a way to build everything that we're trying to include with our reactors. And so as we prove out to these investors, these venture capitalists, they will invest in us and give us money so that we can go do those things. We've already built in Texas, in Austin, Texas. I think it's a 40,000 square foot facility where we are building reactors. We're building reactivity control systems. And you can check out our YouTube channel to check out our factory launch and our other videos that we talk about. That we are learning. We're probably in our teenage phase of learning how to build things and how to design things. We've got a lot of good experience. We've got young people in there. We've got some graybeards in there, but we're growing together through this phase of starting this company. So what is our reactor? We call it the Aalo-1. That's just kind of like the name of the design. Aalo-X is our experimental reactor out at the site, out at the Idaho National Lab. But everything's based on this Aalo-1. The 10 megawatts of electricity, it can power approximately 10,000 homes, a small data center. 5 years ago, 30 megawatts was a good number of electricity for a data center. Today, it's 50 megawatts of electricity is a good launching point for a data center. Who knows, maybe in 2 years, 5 years, it'll be 100 megawatts will be a good launch for a data center. But currently today, we're in that area for 5 of these reactors to match up with a deployment of a data center. And so, like I said, sodium is our coolant. What's unique about us is that we are already using commercially produced fuel. A lot of our other reactor developers, I won't necessarily say competition, but a lot of the other reactor developers are using what's called HALEU, high assay low enriched uranium, which is enriched to just under 20% fissionable materials. We are using commercial grade fuel, which is already produced by companies like GE, Vernova, and Framatome at 5% enrichment, which means we are not waiting on anybody to build up their factories to deliver fuel. We are already just getting in line and waiting for our fuel to be delivered to us. And so that's been a huge benefit to us, that we're not waiting for fuel that is not necessarily available readily. we're working towards a 40 to 60 year plant life. So this isn't something that's going to go away anytime soon. We're trying to refuel 2 to 3 years. Eventually, maybe if we get to the point where HALEU fuel is available in our form, that we can possibly get to even 5 years of a refuel cycle. But right now, we're 2 to 3 years on a refuel cycle. It's very compact. We could potentially get 1 reactor per half acre. So it's very compact. Our emergency planning zone is 1 meter from the building. So what that means is if something was to happen, we have it, that emergency happens within that 1 meter of that building. So that's the plan to get to that level of safety. And then just like everybody else's reactor, passive safety, that's the big thing, making sure that operator interface is not needed to make sure that the reactor shuts down safely. So here's what we call the Aalo pod. And like I was saying, 50 megawatts of electricity is what kind of meshes well with the data center deployments. And so this is what we call a pod. So there are basically 5 reactors attached to 1 turbine that will be built as a unit to match up with a data center. So we're working to build these, and the emergency planning zone will be local, and then minimal local water storage. Like I was saying, about 5 gallons per minute per 10 megawatts of electricity is what we're projecting at this point. So as we find these high energy users, we'll be deploying these pods for the data centers. This image is a little misleading, and we keep using it for some reason, but 2 of these pods will power all of those data centers. So this, you can imagine this being on the other side, and that those 4 pods will be powering those data centers. Our goal is to get to 1 gigawatt of electricity per year, and that's when we will, that will be one of our milestones, that we'll be producing enough reactors out of Austin, Texas to power a gigawatt of electricity. We're working towards making an N+1 configuration, so that high availability. So basically what that means is we can have 1 reactor down or 1 turbine down, but yet we'll still be operating at our advertised production, so that we can always have 1 reactor going through its maintenance, its refuel cycle, 1 turbine going through its maintenance cycle, so that everything can be running smoothly while we're doing our maintenance. The grid connection, I don't know if you've heard of behind the meter or in front of the meter, but there's a lot of benefit to having these reactors behind the meter, which basically means you don't have to give it to the utility, just for the utility to give it back to the actual customer of this consumer. So why that's important is our country is vastly under, what's the word I'm looking for? The distribution lines are not there yet for the amount of distribution of power that we're looking to add to the country. So having this behind the meter option, we don't have to worry about transmission lines back and forth between the utility and the customer itself. So having that behind the meter grid connect optional is a great benefit. We can scale incrementally without being without time and dates. So again, as they're building the infrastructure for the data center, we can match up very closely to what their production and construction timelines are. And then just having that on-site power is very valuable for all of these things. So this is just a slide they added for, just proving out that nuclear power really is one of the cleanest and the safest sources of nuclear power in general. It's got the lowest number of deaths other than solar, and it produces very minimal amounts of greenhouse gas. I don't know the data, but maybe this greenhouse gas is due from the production of the solar panels, but it is very very efficient in the way electricity is produced. And nuclear power really has gotten a bad rap with the accidents in the 70s, and it's really coming back in these years. They keep using the word renaissance, and you don't want to ruin it. But as I was talking to some others in the room, I mean the time is really ripe for a nuclear renaissance for delivery of electricity to the country and the world. So, like I said, we're using sodium as a coolant, which improves the safety basis. The reason why sodium is so interesting is sodium is a very good conductor of heat, which means you can transfer heat very well. And it also is a liquid metal, and so it can get very hot as well without boiling, which is a limitation of water. And so that's why water reactors have to be highly pressurized vessels to really make that efficiency and getting that temperature up to where it needs to be efficient. Higher the temperature, the higher the energy output for your turbines. And so with having sodium as your coolant, you don't have to have a high pressure to keep it for the boiling, because it's got a very high boiling point at atmosphere, whereas water will boil at 200 degrees in regular atmosphere. Sodium is much higher than that. I think it's like 600 Celsius or so where it starts to boil. I'm probably butchering that, but it's very high where sodium starts to boil. So we don't have to have a pressurized vessel. So that means our vessel that contains the sodium can be much thinner. It doesn't have to be a forging, which means our forgings are very hard to get. It's very limited, especially for American supply. So most forgings have to go to other countries where it's cheaper labor force. So our design doesn't require those forgings. We can build our reactors out of thin-walled vessels. They're also small enough to be built in a factory on an assembly line. That's kind of the end goal. Like I said, we're working towards getting 30 reactors built in a year in the near future, and then a gigawatt of reactors built following up. I hear many stories of World War II and of Boeing, but like these factories building complete tanks in 5 minutes, or complete airplanes in 2 hours or something like that. They're rolling a new plane off of the assembly line in 2 hours for Boeing, or tanks in the peak of production in World War II, like a tank rolling off the line in five minutes. We're trying to get to that level of production. I don't know if we'll ever get there, but that's the idea. We can build these things in mass manufacturing with high repeatability and high quality. So that's why this is also, again, a attractive feature of our design. We're trying to make them so they can be modular. I'm sure that you've heard that term when it comes to nuclear. We're trying to live up to that. We're trying to make over 90% of our components in the factory, shipped from the factory in modules, so that they show up to the site, get placed, and there's very small work to connect the two modules together, so that we can essentially, again, the end goal is to get the purchase order to the delivery of electricity very quickly. So that's the point of why we're investing so much money into a factory, other than depending on other vendors to build everything for us. Here's our factory in Austin, Texas. It's very close to the airport there in Texas. And here's some of the things that we've been making. Let's see. Well, this is a jig for fabricating some vessels. This is the frames for some of the proving points of our. So that's one of our vessels that we built. You can kind of see the people standing there. Some welding going on, some vessels being made. Engineers doing some calculations real time to make sure, hey, we screwed something up, and so they're doing analysis real time to figure out the solutions. Here's some shell and tube heat exchanger work that we're working on, and then rolling our own vessel shells in our factory. More pictures of the same, rolling our shells, lifting them up, getting them set into the framework, and installing some of the components and pieces. And again, learning. We're making mistakes. We're learning from them and figuring out ways to do it again the next time. And then here's some welding equipment to try to figure out how to do some automated welding procedures. If you've ever worked in nuclear industry, there's quality control up and down. So you have to prove out that you are doing it to the correct design procedures. You have to prove out that you're doing it to the correct fabrication procedures. You have to prove out that you're buying everything from qualified vendors and the stuff that you're buying is exactly what you asked for. You have to then test it, and then you have to verify that it was built correctly. I mean, we have to live up to all of those things. And again, learning as we go to make sure that we do this in a safe manner and we can depend on what we're building and designing. Here is us loading up some of these modules that we've built, and they're getting shipped here to Idaho, some of our modules that we did for a ship-off ceremony, so to speak. And we're learning through that with learning logistics. What kind of trailers can we get? What kind of vendors can we get for delivery? What would we need for building up our logistical wing and getting these things delivered to all across the country? Austin is kind of centrally located, so that's kind of some benefit there. But then you've got to learn how to ship these things that may be too tall, which routes you got to take to get to different locations and all that stuff, and we've got to learn all that stuff. I've been talking about Aalo-X. This is the materials and fuels complex out 30 miles west of here, and this is our site right here, just right south of MFC. This is us doing a groundbreaking ceremony in August, and within 36 days, our facility was pretty much built. That doesn't mean that we have everything in there. That just means our building was built. There is a joke that we always talk about, and don't take this the wrong way if you worked at the Idaho National Lab, but there's no way in hell you're going to build a shack at the Idaho National Labs within 2 years, and we built our facility in 36-ish days. So the DOE has been stellar at helping us accomplish these things and removing the red tape and helping us deliver on these things and proving out that it can be done, that they're learning just as much as we are. This is totally new ground. If you've ever worked for the Department of Energy in any form or fashion, you would be mind blown at how much we are getting things approved and pushed to get things moving forward. You can see on LinkedIn all of the different reactor programs getting their documentation approved. We're trying to get there right there with them, but it is not just us. There's many nuclear developers out there that are going just as fast as we are, and we're all racing. It's a nuclear race, just like the space race at this point. But we're not going against countries. We're going against ourselves to prove out that this can be done. So what are we planning on doing? In this year, and I can't give you an exact date to what we're trying to do, but very shortly, we're going to be going critical with our first low power tests in that facility. It doesn't look fancy, but it'll be functional. It's a 60-foot wide, 60-foot deep by 60-foot tall building that we're going to be putting our first criticality vessels in there. And then by 2027, we're hoping to do full power operations in a facility just to the west of this facility. The DOE was nice enough to give us 2 acres. 1 acre is housing this critical facility, and then the other acre is going to have that full power test. So here's kind of our technology maturation. So in Q2 of 25, we built what we called the NAV, which is a sodium vaporization test rig. We're trying to figure out how to play with sodium. We're doing the same thing with our STL, our sodium test loop, which is down in Pocatello for some of you others. And then we're working to build our Aalo-0 facility right next door to our Aalo critical assembly. What the Aalo-0 is a non-nuclear prototype. It's going to be basically a full-size vessel filled with sodium, approximately the same amount as what we would have in our reactor, but we're trying to prove out some things, make sure the sodium acts the way that we are predicting it will act in our analyses. And then once we've gone and done all our lessons learned with our Aalo-0 facility, we will then have some good learnings to go to our full power nuclear reactor. And then once we get through some experiments with our non-nuclear reactor, or our experimental reactor, we will then be taking orders and cashing checks for the pods. Yes. So very similar to what EBR2 did. They use sodium to generate the heat. They use nuclear power to generate heat within sodium. And we pump that sodium through a heat exchanger, which then is to another sodium loop, which is our secondary loop, which will then generate steam. And then it'll just go right to a commercial off-the-shelf steam turbine generator.
Sorry. So what are we going to use if we have some thermal runaway problem where we have to get rid of the heat, but we don't have?
So the air-cooled condensers, we're going to size those for full 30 megawatts.
See. Okay, thank you.
But so we'll be shutting down the reactor, obviously, and then just letting that heat kind of dissipate as we pump it through, and then use the air-cooled condensers to also help cool us down. But we will have our decay heat system as well to help remove that heat as well, to make sure shutdown will happen, and then the decay heat system will help remove the heat from the primary system as well.
Thank you.
Everything else will be kind of like a backup power system, a backup defense in depth is kind of the term, to remove the heat quicker, but we will be designing that decay heat system to handle a shutdown with a full temperature reactor, if that makes sense.
You lost me there, but never mind.
So let me try to explain it a different way. The reactor will be at operating temperature. We have a trouble, so we'll shut it down. We'll have methods to shut it down, and then the decay heat system removal.
What decay heat?
That's just like you got like a bathtub in ambient air,
yes.
And we will design that decay heat to remove that heat so that it won't melt anything down.
Thank you.
Yep. So by the time we get to the pods, that's when we will be converting our DOE license strategy to the NRC license strategy. And that's when Idaho Falls Power might be getting more into the, hey, when do we get ours? And we are at this point right now, obviously, getting the Aalo-0 ready, getting Aalo-X ready. And hopefully within the next year, you'll see nuclear power getting generated out there. And again, we got Pocatello with the NAV and the STL, and then INL is where we're building this, and then across the USA is where we plan on deploying the pods. So this is just kind of showing why we're using Aalo-X. Aalo-X is going to help us prove out our technology to make it easier for NRC licensing. DOE is used for research and development. They're helping us, give us the leeway to do a first-of-a-kind reactor and figure out these tests so that we can prove out, hey, this is what happens when things go wrong. We prove those tests out, and then NRC will use those studies to help for basis for providing a license for a reactor commercially. And so we are in talks with DOE, we are in talks with NRC to make sure that they both are cognizant of our safety strategy and making sure that they understand our design so that the licensing will happen smoothly. So benefits for Idaho. Why does this matter for you guys? Again, I talked about this: operations, engineering, maintenance, admin. They're all here in our office in Idaho Falls. A lot of them are local, a lot of them are imports, and that's going to happen continually as we grow and need more people to help us. Indirect, we're bringing in some from out-of-state contractors, so they're going to be bringing in temporary workers. We're going to have security. We're going to have other subcontractor jobs for construction and logistics and all those other things. Currently, we have 50 is a little strong, but we do have a large office here in Idaho Falls. 40 plus is probably where I would be for Idaho Falls. Economic development, we're enabling the building of tech campuses and more jobs. We are needing operators, and the Navy doesn't make enough of them, so we're definitely looking at options to make more operators, and maybe talking in the future, maybe there will be a program developed at some of the local universities to create these operators that we need. And then just of benefit, just more reliable, clean electricity. One of the reasons why I joined Aalo is I have a bucket list to have a nuclear reactor built in Idaho that's providing electricity to Idahoans and not just as a research reactor. So this is one of my things that I will take much pride in, is to provide a reactor that will provide electricity to my family and others within Idaho. This is us just it's a couple months ago, but again, you can see we are growing, and we do need help. And I don't know, I guess we'll just kind of open the room up to questions if you have any. Yeah, come on to the mic, please.
Actually, I can think of about 4. First of all, will you be generating sodium-bearing waste? And if so, where does that go?
I do not believe so, because we're not doing research. If anything, we will be activating a small amount of sodium within the primary coolant system, but that will decay down eventually, and it'll just be, it's not like we're going to create any fission products that will stay within it that will not decay out. So I do not believe we will be creating sodium-bearing waste.
Where does the spent fuel go?
That's a good question, and Idaho's asking that question because of the DOE reactor. We haven't got the answer yet with that. We are working with the Department of Energy to come up with that solution for the Aalo-X reactor. When we go to an NRC license, that's going to be part of that license where we're going to have to come up with where does our spent fuel get stored at. The problem is we just don't have the money with our venture capital to come up with a good plan for that. So we're looking for help from the DOE to come up with a solution for storage of our spent fuel. We're getting close there, but again, Idaho is definitely interested because of the BAT agreement. So we're working through those things.
Okay. What about the water? Have you procured rights to water to run this thing?
So we're going to have to, for this reactor, we are working with Idaho National Lab to get that water source provided from the MFC, and it'll all be within their already allowed amounts of water usage. We're not asking for anything in addition to what they already use.
Have you guys talked about military applications for this?
Yes, we are not obtuse to it, and that's all as far as I can go with that discussion.
Okay. Got it. Thanks.
Yes.
I don't know if you're aware, but ISU and ITech both have nuclear operator training programs that may be useful for you.
Oh, well, I appreciate that. Thank you.
Although I would go with ex-Navy if you can get them.
Yep. And that's who we have right now. We have 3 ex-Navy operators right now.
The other question I have for you is you mentioned the distribution system is not great. What are they going to do with the power that Aalo-X produces? Because you have to run a turbine to actually prove the concept, right?
Right. So that's another interesting question. Me, as an engineer, I hate generating energy and then having to dump it into the atmosphere. And so that's kind of what we're having to do at this moment. But we are working fervently to make that electricity of use to Idaho.
You can't connect it to the loop and sell it.
So I don't know if I can speak too much to the details, but it gets, we get into legal mumbo jumbo between Idaho National Labs and Idaho Power, who supplies power to them, and Rocky Mountain Power, because Idaho Power, they want their cut. So they don't, basically the DOE has a restriction, I think. And again, I'm not trying to butcher any agreements or anything, but basically they can't self-produce their own electricity due to their agreements that they have with.
That's not true. We did it with EBR1 for years.
And I understand.
Pardon, EBR2.
Sure.
but we couldn't sell the surplus. We actually made surplus power.
Right. And we are trying to come up with a way that makes everybody happy so that that power is used for good.
The other question, I'm trying to visualize these pods.
Mm-hmm.
Any turbine with condensate system and everything I've ever seen that would generate that kind of power is much too large to fit on the back of a truck. What kind of turbines are we talking about here?
So these 10 megawatt turbines, they're actually not that bad. I don't have any pictures of it, but they will fit on an 8-foot wide by about even a, comfortably, I'll say 20. I think it might even fit by on, I think it's closer to 20. A 20-foot long by 8-foot wide.
So when you're saying
Connex
pod,
box.
the pod itself is not not shippable as a unit. You have to ship
Right.
pieces.
There will be, I'll just throw a number out, 50 modules that need to be delivered to the site, and then all of them interconnected to get the plant operating.
Okay. Well, that's all I really have, other than I am concerned. I've been in nuclear business almost 40 years.
Right.
I am concerned about the long-term disposition of the waste, not just yours, but for the whole country.
Right.
You know, and that's something that maybe these venture companies could exert some pressure. You know, because Harry Reid screwed over the whole country with Yucca Mountain.
Right. So I don't think they'll kill me for this, but very long term, we're not going to make just Aalo-1 reactors. There's going to be reactors that follow up to this one. And I think it's safe to say that our future reactors will try to use up some of the spent nuclear fuel or breed. We might get into that breeding of fuel, but I can't say without for sure what that will look like. But don't count us out. If we are successful, Aalo-1 will have a next generation reactor where we envision trying to reprocess or breed more fuel so that we don't have to deal with all this spent nuclear fuel. Oh, he's got a good one. He's chuckling as he's coming up.
Well, you're actually talking my history now, spent fuel. So the DOE hasn't been able to solve its own issues with spent fuel.
Mm-hmm.
Not only DOE's fuel, but commercial, all that's been here forever. And you mentioned the BAT agreement, the 95 settlement agreement. I understand that very, very well.
Yeah.
So the question that I have on these things is how much, if you're planning on full power in 27, how much do you expect how much spent fuel do you expect to generate? Okay, because that's going to be hot. Okay, where is that first look? When do you change them out? When does the core change out?
Right.
And then where are you putting it?
Yep.
And who's liable for that?
Right. So we are planning on a refuel cycle of 2 to 3 years with the 5% enrichment. I don't know if I can give you the full details on how much weight, but it's that I can tell you that vessel is about 10 feet in diameter and about 20 feet tall. Our active fuel height is about 2 meters. So you can kind of guesstimate how it's not that much in retrospect to gigawatt size. As I talked about earlier, the spent fuel for Aalo-X, we don't have a great solution for that yet, but it is current discussions right now with DOE. We're working with the DOE to accept that spent fuel for Aalo-X. But when we get to the pods, where it's NRC, that's where that part of that license, we got to have a fuel storage strategy for that spent fuel.
Right. Okay. So you're asking the taxpayers. Yeah. If you're asking DOE to take the fuel, you're asking the taxpayers to assume liability for that.
In a long and short of it, yes. In the long and short of it, yes.
I mean, it is what it is. Okay.
Yes.
If DOE takes it over, so the question would be: do you have an agreement with DOE in place already to do this? you say you're in negotiations with them, but if they're letting you build on their site, there's obviously some thought that had to go on. Have they already committed to at least take part of that?
So I won't speak for DOE Idaho, but I can guess that they're not going to let us start this reactor without a solution to that question. Where's the spent fuel going to go? So that's why we're working on that currently, to figure out where that strategy is for that spent fuel to go.
You see, that's a question that's been going on for 40 years. Well, since they shut down reprocessing.
Right.
And that's a literally a multi-million-dollar question that every nuclear power plant is facing today.
Sure. So today, we don't know how long Aalo-X is going to last or run. So is it going to be more than one cycle? I don't know. Is it going to be even a full cycle? I couldn't answer that question either. So that fuel that we have in there, will it need to be stored somewhere, or will it just be sitting in there waiting for its next job? But I can tell you, we are trying to get a plan for long-term use of it. And I can guarantee you that the storage of the spent fuel will be figured out. And I will put my reputation on the line and say this, but if we do get that to happen, where we're running for 30 years, I can guarantee you that Idaho will not be paying for the storage of that fuel.
Well,
It'll be on.
I would not make that guarantee. Idaho.
What I'm saying is
taxpayers are making that.
What I'm saying is whoever's buying the electricity will be paying for how that storage is being used.
Okay. Yeah, the data centers. Okay, yeah. Okay, just another question. Like I say, spent fuel is a big issue. It has been across the country. You touched on it a little bit, but I think it's, that's a make or break thing for a lot of these, of reactors. That's one of the main reasons why a lot of reactors, new commercial reactors, haven't been built.
Right.
It's because it's expensive, to build and all that. Plus, there's no place for the fuel to go.
Yeah, a lot of them just stored on the site in their
We have
dry
fuel
casks.
stored on the site here. I mean, up until recently, we couldn't even bring commercial fuel on the site. And so every commercial reactor across the country has their own storage.
Right.
And so if on that aspect is, let's just say you build some of these off the lab on the outskirts of Idaho Falls, and Aalo is responsible for it, are they going to maintain that responsibility in that spent fuel storage area forever? Or is that unexpected for the state of Idaho?
No, I'm sure it'll be exactly the way other nuclear power plants are. They are responsible for their own dry storage. They're responsible for maintaining it. I'm sure we will be just as beholden as the other nuclear power operators will be. We are not, and by that time, we hope to be a public company and not beholden to venture capitalists, so to speak, but a self-sufficient company that we would be paying for our own.
Okay, well, hope's not a strategy,
right.
By the way.
Well, and when I say that, I hope that's the strategy. We're expecting the revenue that we get from our power purchase agreements to be able to pay for all of that logistics and everything else.
Yeah, I understand the business model quite well. I just also know that there's this one hiccup in there that causes a problem. And when you talk about reprocessing and recycling the fuel, that's a whole nother discussion.
Yeah.
Where you said that you hope to be able to use your waste to maybe fuel future reactors. That's a whole nother discussion.
That's science fiction. I agree. But
it's not scientific fiction. It's possible. It's politically science fiction.
Yes,
So we used to do
I agree with that. Yes, for sure. But what I'm saying is,
we know how to do it.
That's not anything that we're working on today. But I'm predicting that we will be working on that if we are successful.
Okay. Well, I hope you are successful, and I hope all the other reactor companies that are around, trying to do these things are successful too. Because I'm a pro-nuclear. I spent 40 years out in the lab. I know a little bit about this stuff.
Yeah.
And so there are some things that have happened that I don't agree with, but that's how it is.
Yep.
And so they're going to be your challenges. So spent fuel obviously is a number one. Who's going to do it? The state. I don't know how that plays out. That'd be interesting. again, okay, so another thing here is if you build off-site, like here on the outskirts of Idaho Falls,
Right.
what kind of security and stuff you're going to do? How do you, I mean, the world's a little crazy right now, and what about a terrorist attack on it and whatnot? And sodium, you throw a bunch of water on sodium, it's not a pretty sight.
Right. Nope, it's not.
So
Good question. Right now, we are working on an interface agreement with the Idaho National Labs to use their security forces to help us with our security, but that's not going to work for us out at the Idaho Falls Peaking Power Station. So we are working with the NNSA, National Nuclear Safety Administration, something.
National Nuclear Security, yeah.
So we are working with the NNSA to come up with answers for this, being prepared for those security concerns and making sure that our future pods will have the security that they will necessitate to make sure that nefarious people don't do nefarious things. So we don't have all of the answers for that right now, but we do know for sure that we will need that to get that NRC license.
Yeah, well, I think those are good questions. Like I say, I'll just step back. I'm a proponent for nuclear power. I understand that. But these are questions that you're going to have solid answers to be able to go there. And I think even to be able to get the community to support it.
Sure.
And all that. So
let me see if I can get back to that picture. But we don't want to we don't want to have the NIMBY people coming in and trying to destroy it. The NIMBY is not in my backyard. So the idea is that we would want this in our backyard, and we need to address all of those questions so that the community would be comfortable. But yeah, having a massive amount of sodium, as you alluded to, is not exactly the most comforting thing for somebody to have in their backyard. So it is on us to provide you with that comfort for something like that to be in your backyard.
Okay. Thank you very much. I appreciate it. Like I said, I just know a little bit about that.
I appreciate the hard questions because you're right. We do need to know what we're going to do for security. We do need to know what we're going to do with our spent fuel. It's very valid questions, and we do need those answers. So I appreciate you bringing them up to keep us fresh in our mind to come up with those answers.
Okay. Thank you.
Thank you.
So I Googled how many nuclear power plants is China building. On Google, it tells us right now there are 30 to 38 nuclear reactors under construction in China.
Mm-hmm.
By the year 2035, they want to have 150 new nuclear reactors built and online. We read that France has 75% of their power provided by nuclear power.
Mm-hmm.
I think as far as the world is concerned, nuclear is the way to go.
For sure.
Yet in America, it does seem like we have all these lawyers and special interest groups that are just going, no, we want you to live in a cave.
Sure.
And we don't want you to have access to any kind of energy source. But does the national perspective give you guys any optimism?
Currently, yes, for sure. President Trump, like I stated, he put out those 4 executive orders and requested this reactor pilot program get instituted. So that's the nature of the beast in American politics, though. What's going to happen in the next 4 years? So, yeah, that is the biggest concern that I have, is those are 4 executive orders. Those are not law. We need to pressure our lawmakers to make those 4 executive orders law to make sure that this continues. We've gathered this momentum in this last 4 years. Let's continue pushing for that. Now, the benefit is both sides of the aisle are seeing the benefits of nuclear power, but there is still a lot of NIMBYism out there. No, they don't want it in their backyard. They don't want it at all. American power generation, I think, is around 20% nuclear across the country. And I agree, we need to be exceeding France, in my eyes, for the amount of power that we produce for our country. Does that kind of address? You're back.
Just 2 quick thoughts. We are reprocessing fuel right now. That's what HALO is reprocessed fuel. So it's not impossible to do it. You just have to have the right technology. The other thing that I'd like to point out that's different about this nuclear renaissance is it's not driven by the government pushing technology. Department of Defense, Department of War, rather, is actually involved a little bit. But the money people with the data centers is what's driving this whole process.
True.
And the American public will at some point be told, if you want AI for your damn phones, you're going to deal with nuclear power or you're not going to have it.
Well, I think they're going to be told if you want to keep charging your cars,
Or charging your cars.
you're going to need to figure out a way to provide the electricity.
So I
needed.
think that's a key factor. The driver is different for this one.
Yeah, I mean, this is kind of anecdotal, but I believe it to be true. But I believe the Californians have been told to not charge their cars at night in some areas of California because the power demand was not there
They
for
can't support
the
it.
charging of their cars. So how are they supposed to get to work the next day?
Just as a question, what are you listed on an exchange yet, or is it private?
No, we're still private company. With luck, we'll be a public company in the near future.
Thanks.
Thank you.
I guess I don't see too many women here, so that's why I'm kind of encouraged to come.
Yeah.
So I'm a physicist, and I used to work in INL until December. So I'm from Poland originally, where they try to build some nuclear power, but they are very low. I have a couple of questions. First of all, so you started with Marvel. Is Marvel not what Aalo-0 should be? Is it not the same thing?
So Marvel had a different purpose. When that project was started, it was, and it was a brainchild of Yasser Arafat, our chief technology officer, one of our co-founders.
Right. He was
The
there.
idea was, we have forgotten how to get reactors built. Let's figure out how to build reactors. So the original scope of the Marvel microreactor was to build a reactor and generate electricity, start to finish, in 2 years. It was a grand ambition, dream, and we accomplished the 90% final design, very close to that 2 years. It's not operating yet, still to this day, but they're getting closer. So with that being said, the Marvel microreactor was not designed to be a large generator of electricity. Success was generating electricity, not 10 kilowatts, not 10 megawatts. It was just generate electricity. Make sure that we can go through the process of going through a design, going through the paperwork, going through the licensing, and building it, and figuring out how to flex these muscles that have been atrophied in America for so long. Marvel was the first reactor approved by the DOE ever. The DOE, the reactors that were built at the Idaho National Lab prior to DOE's founding was all done by the AEC or whatever. DOE had never authorized a reactor for fabrication. So 50 years that we have not, the Department of Energy had not approved a reactor for construction.
The new design, you mean? Yeah.
Just any design. I mean, the advanced test reactor had gone through design iterations and stuff, but that wasn't like a full-on, you're approved to go build a reactor. So again, the Marvel microreactor, it wasn't built for efficiency. It wasn't built for generating massive amounts of electricity. So it's just a different form and function for that reactor. So it's not built for commercial deployment and generating massive amounts of
it doesn't
electricity.
have really the fuel, right?
Say again?
I don't think it was built for really working with the fuel, operating with the fuel, right?
Right.
I thought this showed the sodium, though.
Yeah,
Is it not?
It's actually a NAC cooled reactor.
okay.
A little bit worse than sodium.
Okay, so it's potassium.
Liquid metal, though. It's liquid metal, and it uses
Mm-hmm.
a different fuel function, a fuel form. It uses trigger fuel instead of the fuel that we're using.
Oh, I
but
see. Yeah.
Slight differences, but anyways.
Okay. And UO2 reactor, it seems like all nuclear reactors, the civil reactors actually work on it.
Yep.
So I don't think it should be a big deal because you talk about very small power compared to the, civilian nuclear reactors, which have like 1 mega. And this is like 10 kilo, right?
Yep. No, 10
Okay.
megawatt.
10 mega?
10
Oh, okay,
megawatts.
sorry, it's not 100. Or it's not like 300, which is the other. Okay,
yeah, there we
the
go.
other question. how are you interconnected with really INL? You basically build it on INL side.
So we had what we were doing originally, very early on, we were working through the Nuclear Research Innovation Center, NRIC. That was a DOE program created to help, again, it was one of the programs that started the momentum for getting nuclear developers started and building reactors again. So I'm sure you've possibly heard of Project Pele, and there's also other companies that are using NRIC that were originally using NRIC to help deploy their reactor technology and test it, just like we're doing. And they actually converted the EBR-2 dome to the NRIC,
I do remember
the
that.
NRIC test bed. So a lot of these nuclear developers are putting their reactors into the NRIC dome and running them in there. The thing that makes us different and unique is we're building everything. We're building the building. We're building the reactor. We're building.
You're doing it parallelly. It's kind of crazy because you do it in Austin and then you move it over here and you kind of like expect, you want to do it fast. That's why you want to do like all stages, I guess, in the same time, right?
Yep.
Do you think maybe since sodium reactor run on high temperature, maybe you can also use it for like chemical reactions?
Yes.
Because this is another.
So we are talking
application.
about that.
Okay.
The problem with temperature, don't want to get too nerdy here, but you're a physicist, so you might appreciate some of this. But you get too hot in temperature, you start changing the material properties and start putting in creep into the metal. Creep basically means you affect the material properties because it's so hot for so much amount of time.
You have lots of corrosion when you talk about sodium anyways.
So there's benefits to going higher temperature, but there's also benefits with just staying kind of at a higher temperature, but not super low either. But yes, we are definitely talking to people to use it as a process heat or a high-grade heat extraction for some of our reactors. Dow Chemical actually has an agreement with a nuclear developer for doing something just like that.
And you said there are like 10 different companies that have paid right now, because I know lots of people just left INL and they work in this company, like 50 to 100 people.
Yeah.
So do you think any other company, are they connected also to the INL integrated like you are, or
Yes.
do they also, are they going to go faster than you with
hope
like
not.
reaching critical?
But yes, like I said, we're in kind of a nuclear race with each other at the moment.
Okay, thank you.
But yes, a lot of them are talking with the Idaho National. It's not, and see, that's what's unique. The NRIC program is a DOE program, but it's also at the Idaho National Lab. So, yes, a lot of these developers are talking to the same people that we are talking to at the Idaho National Lab, at NRIC. Some polite, the question was, do we talk to the other nuclear developers? And maybe way high up, they probably make fun of each other, but I don't necessarily have regular conversations. Yeah.
Hi, I've got a question, I guess, more on the data center side. I'm an IT geek. You did my time out at the INL, probably like most of the people in this room.
Yeah.
And consult on data center design and things of that nature. And the big thing they are running into is the lack of power.
Mm-hmm.
And you talk about, being able to supply 50 megawatt, 200 megawatt for a standard data center. There's currently 2 new construction sites in Indiana that just broke ground in the last few months that are anticipated to be each 1+ gigawatt data center sites.
Right.
And so, people alluded to it that AI and all of this compute capability is really one of the number one drivers of, acknowledging the lack of, electricity in this company or in this country. So I guess I'm looking at this from a couple different perspectives. I've reached out to the INL. I haven't gotten any feedback yet, but what are the plans? They actually put an announcement out. I don't know if anybody in the room remembers this. It was 2 or 3 months ago about we would like data center providers to be looking at us to come into the area.
Mm-hmm.
And, what I'm curious about is even if we get the power infrastructure here, that why I want to talk to the INL and other people in the area. We haven't addressed the data. We don't have the data connectivity in the area, to supply this type of thing. But that can be built out. It can all be built out. But I guess I'm still interested in the BAT agreement, because I remember when I first started at the INL that no electricity produced out on that facility could be used for commercial use. So evidently there's been some change or something in that policy. Is that correct? Does anybody know?
So again, they're working through those logistical changes. Idaho, like I said, has been nosing their way in to be like, hey, what about this thing over here? How are we going to address this? I don't have all of the answers for that, but discussions are happening to make it so that we can bring a data center to Idaho.
Well, that's good. I'm glad to hear that, because I know a lot of the public isn't aware of that. I know a lot of us that worked out at the INL, we were aware of that, that no power produced out there could be sold and used commercially because of that agreement in Idaho Power, Rocky Mountain Power, and the different companies didn't want the competition.
Right.
So anyway, all right, just make sure it's being addressed. Thank you.
Yep.
I'll just comment on that. I think the issue is it's nothing to do with the BAT agreement, that prevents power. What it is the government can't go in competition with the commercial industry. And that's why EBR2 produced a lot of power, but they never went anywhere, because the government couldn't produce power that would, in essence, lower Idaho Power or whomever, Rocky Mountain Power, Bonneville Power Administration Power. So the government can't go in competition with private sector. And that's why, we never, EBR2 and all that, it produced a lot of power, but it never went out on the grid.
Right, and so to get around that is to hope, I don't know if I'll be giving too much away, but trying to get away from the government competing with providing that power. I'll say that. We'll try to get around that in a different way.
Well, in this type of situation, in reality, it's the government isn't providing the power. Aalo would be which is a private industry, would be providing the power to Bonneville Power Administration, whatever. So that's how they would get around that.
Yep. Those conversations are too smart for me, so I just...
Sorry, I came in late, so maybe you went over this already, but did you go over kind of just like at a high level, your systems of Aalo kind of as they stand now?
This is kind of as high as we went. We talked about that it's a 30 megawatt thermal, 10 megawatt electric is kind of the Aalo-1 design with sodium coolant, and we're using UO2 as our fuel, which is commercial fuel as it is. All of the commercial reactors in the States currently use that fuel.
Okay, so like the cylinders on the top section, can you talk about those or any of the other components of the system? Or
I could, but they're not really valid anymore. This is a pretty old picture. But basically, we'll just be using pumps to circulate the primary coolant. Those pumps will pump it through a heat exchanger. That heat exchanger will transfer it to a secondary system, and that secondary system will generate the steam, and then the steam will go through a commercial off-the-shelf steam turbine generator and generate electricity like most other power plants.
okay, thanks.
Yep. Thank you. Good sir. I used to work with him.
As I look at that figure, I was trying to figure out how you're going to get the fuel out to recycle it. Is that center section up there, the round, is that a way to withdraw the fuel rods?
So we can kind of talk
like a lot to remove otherwise.
Sure. I can kind of tell you what is in the picture, and it's similar to what our current iteration is. These cylindrical things are just electric motors running the pumps down here. This box here is the heat exchanger. We're pumping the coolant through the heat exchangers, and then the secondary coolant will be coming out of those pumps there. This cylinder here is just the control rod drive mechanisms that removes and inserts the control rods to get the fission to happen. And then the fuel is down here with some shielding surrounding it. And then if during a refuel cycle, we'll remove the control rods and just pull the fuel out from that center hole in there, essentially. The question was, do we have to take out all the rods? But no, the rods will be with the fuel pretty much the whole time, so that for critical safety. Criticality safety.
So is this thing's all above ground, or does it go in the ground? I'm assuming it would be above ground, since it's kind of going to be delivered in a shipping type container. Or
So that's where some of the learning has been happening. We're still trying to figure that out. We just dug a 50-foot hole out at our site to do just that, put the reactor in the ground. But now we're wondering, is that the right way to go? Is it the right way to do that at every location? We're still trying to figure that out. So I don't know is the answer. That's why my hair is turning more gray. We're still trying to figure that stuff out.
So if you don't put it in the ground, do you need to shield it?
For sure.
Or you can use lead, or
that's the trade-off. I don't know, but that's the trade-off. Do you have lead? Do you have concrete? Do you have borinated that's going to be the trade-off. If we don't put it in the ground, well, now the shielding is going to have to be a lot more on above ground. So that's where we have to find that happy medium spot. Do we dig the hole, or do we build the shielding?
So if you do stick it in the ground, do you need to redo your physics for any of the neutron reflection that
You're asking nuclear engineering stuff and
Okay.
the magical neutron stuff. I'm sure I'll be wrong no matter what I say.
His comment was he's making him glad that he's retired. And with that, let's give Luke a big hand. I'll have to say, looking across the room here, you probably walked into a room with some people that have a little bit of nuclear experience under their belt and have dealt with the lab for quite a while. And so this is an interesting topic. And as you can see, there's still a lot of questions, unanswered questions in that. And I'd just say you're pretty ambitious if you don't, by 27, you have a lot of questions you need to really answer. So
You ain't a kidding.
So definitely. So
that's one thing that Yasser is not, and that is patient. So we have to, we've got a lot of work to do, and so that's what we're trying to do. We understand that there's a huge gargantuan effort, and we're doing our damnedest to make sure that we do it.
Well, I appreciate that, and I think a lot of people here are supportive. We just know where some of the pitfalls are and all that, and we're glad people are out there trying to make it happen, because I think that, like I say, from looking across here, we have a lot of pro-nuke people, but we know what you're up against, and so that's what we're talking. So let's give them a big hand, another big hand, folks. And
thank you.
And do you have any last comments you'd like to make? Or
if you want to learn anything about us, aalo.com, or Aalo for those within the company, just aalo.com. You can join on to our newsletter, and we send out, I think, a monthly newsletter to tell you the status of where we're at. We have our job postings posted there, and announcements on LinkedIn to see how blazing fast that we're trying to get things done. So if you want to reach out to us, you can reach out to us via those mediums.
Well, it's the middle of February now. Maybe we'll get you to come back, or somebody come back in about 6 months and give us another status of where you are and all that. So that work?
Can do.
All right. Well, thank you so much, Luke.
Yes.
I appreciate it. And
thanks for the invite.
Yeah, you bet. And with that, folks, I'm just a reminder. This is a great thing. I'm just a lot of challenges, as we all know. Really encourage us all to come and listen next week. An Article 5 convention is not a good thing, and it's bad. Also, real quick, before anybody leaves, if you've heard about the grocery tax repeal initiative, if you agree with it, there's a lady here in a white hat that has a petition. She's trying to get everybody to sign it. If you haven't signed the petition, they've got to have something like 70,000 signatures by the end of April. So if you support that, see her and sign it. But anyway, come and listen next week about the Article 5. Learn about it because it's important. We could be here, we're here today because of what happened 250 years ago. And in Article 5, some people think that it is a very good opportunity to actually destroy the Constitution that we have. And I'll just let it go at that. And then the following week, March 4th, is a really important one. It's all about our children, internet safety and internet crimes against children. We need to recognize what it is and that it's there and what we can do about it. So with that, thank you, everybody. Take care and be safe going home. Hey, we got a little bit of weather, so finally, so take care. See you next week.